What are black holes?
Black holes. Wow. So can we go for that? Because nothing inside the black hole can communicate something that is outside, and nothing outside the black hole can't communicate something that is inside a black hole. Okay.
But what is inside the black hole?
Singularity of a Big Bang is same as singularity of a black hole.
It is like shunya bhi mein, sab kuch mein. It's like, infinity. It comes back to its
It's a
original.
hyperspace perspective.
Yeah.
Can past create the present? But
How? Define God.
everything and nothing, both. Where is Vishnu, Lord Vishnu laying?
I don't know.
He's laying in hyperspace.
You know about Shiva's Damru? Then the swing of it, the rotation of it, the movement of it, it ends up creating the symbol of infinity. You see? So what it basically says that, I have no start, I have no end. I am and I am not.
Time doesn't exist for you if you travel at the speed of light.
Which is everywhere and anywhere. No, but do you think that there exists life apart from our planet also?
Of course I do. Like, the aliens must be very common in this universe, or there must be no aliens.
But how can you say that? Don't you think that would be very ignorant to say or think? Because we do not know the possibilities of the universe, because it is infinite. It is insanely huge, large, vast, already and every time expanding.
Exactly.
Shrotagan, welcome to your podcast with Raj.
What are black holes?
Black holes. Wow. So can we go for that?
Yeah, go ahead. I'm ready.
All right. So you know what? There's some escape velocity. Everything, every planet has, every star, every celestial body has an escape velocity.
Yeah, even us. Like, we have to escape the Earth's atmosphere through a certain velocity. Only then we'll be able to get out of it.
Yeah, it's 11.2 kilometers per second for the Earth. Okay. Now, let me explain the black holes. I will not explain it in terms of hyperrelativity, my new book, because it will go too complex, I think.
Aren't we too complex now? Are we on a very basic or a very simple level still?
Let's go it for simple a bit, I think.
Okay.
Let's go for it.
Let's go for it.
Yeah. So we are having some escape velocity, right?
Hmm.
So for Earth, it is 11.2 kilometers per second.
Damn.
For Sun, it is something like, I don't know the exact number. I have to calculate it in front of you. So let's say for Sun, it is some speed. Okay. For Jupiter, it is for some speed. Now, as you go, there's many stars, like larger than the Sun. Okay. So the larger the more gravity, the larger the more massive the source becomes of gravity, the more is the escape velocity which you have to get, if you want to escape that thing. Okay. That star or planet. Okay. But especially stars, they have like a huge escape velocity. Okay. Now imagine, as the escape velocity goes on up and up, as the stars get larger, or the gravitational source or the source of gravity becomes stronger. Now there's an extent to which how massive a star can become. Okay. Because what happens in massive stars, they are fusing the material inside them. Stars basically run at an equilibrium. There's always an equilibrium in the stars, of gravity. There's a lot of material in the star which pulls the outer surface inwards, totally inwards, and what balances the star is the nuclear fusion happening hydrogen to helium, helium to carbon, and carbon to nitrogen, oxygen, and a lot of materials. Okay. Last to iron. Okay. Now what happens, the massive stars, when you talk about, they keep this cycle. It's not a cycle, but they keep this equilibrium to an extent, because as the elements get heavier, okay, when you fuse hydrogen, like if the star is new, it has hydrogen. Okay. It fuses to hydrogen. Now it forms a heavier elements like helium and then carbon and like a lot of materials. But the heavier element gets, the more the star has to.
Helium the lightest gas?
It's not lightest gas. Yeah, hydrogen gas.
Okay.
Yeah. So basically, yeah. So the lightest form, is in star is the hydrogen. Yeah.
Okay.
So helium to hydrogen to helium, helium to nitrogen, carbon to nitrogen, and so on. Okay. But now there comes a point in the life cycle of a star where it has no more lighter elements to fuse, and the last element it can go to is the iron, and iron is infusible. What happens? The tug of war is always going on of that, nuclear fusion and the gravity. The tug of war is always going on. And what happens at that point is that once you have iron, it can't be fused, and the tug of war is won by gravity. Now, though, if the star is massive enough, then it forms a black hole. A black hole is basically, it's a case where the escape velocity is itself the speed of light, the fastest speed of the universe. We talked about escape velocities. For Earth is 11.2 kilometers per second. But the stronger the gravitational source is, imagine a star that collapses into a black hole has so much material and all that it has escape. Once it gets that escape velocity c, it gets a black hole inside it. Okay, and yeah, so when there is escape velocity c, we just have that black hole. And how it looks like? It looks like a portal. It looks like a portal. It looks like a 3D sphere. I think many of the audience must be knowing about the black holes. If you watch the movie Interstellar, like black holes are pretty quite famous. Around, it's very popular. Yeah. So the thing is that if you know the boundary of a black hole, it's called event horizon, because
Okay.
nothing inside the black hole can communicate something that is outside, and nothing outside the black hole can communicate something that is inside a black hole. Okay, so inside the when you talk about the event horizon of a black hole, it is something which marks the boundary. It's a horizon in space time. What does the horizon of space time means? That boundary, that things beyond the horizon. So that's the event horizon. Things inside the black hole can't communicate things outside it, and things outside the black hole can't communicate the things inside.
But what is inside the black hole?
Let me come to that point. Okay, let me come to that point.
Okay.
So yeah, when the escape velocity comes to the c, you just have a black hole. So when you are on the surface of a black hole, that three-dimensional portal, black portal, okay, you have to travel more than c to escape it. Just like Earth, we have escape velocity of 11.2 kilometers per second. So if you want to escape the Earth, okay, you have to travel more than 11.2 kilometers per second. Similarly, in case of black holes, it's the escape velocity of c. And if you want to escape a black hole, you have to go faster than that. And is it possible to go faster
I
than
don't know.
speed
It's
of
not
light?
possible.
So it's not possible to escape a black hole.
So you get stuck there.
Yeah. It's not just stuck there, but you get inside it,
You get sucked.
get stuck inside a black hole, and then you fall into a singularity. A singularity in time. Now let me tell you, as you just asked me, like,
So
what
anything can get sucked, like an astronaut or a satellite or anything, any debris.
it's black hole for its lunch. It's stars for its lunch. Huge black holes like Milky Way galaxy, Sagittarius A, M87 black hole. It's massive stars that are thousands of times larger than a sun. It eats it for its lunch, just like breakfast.
But what what happens once it goes inside that black hole?
That's the part of what is inside a black hole, right?
Yeah.
Yeah. So let me explain what happens inside a black hole. Now, in traditional sense, when you talk about space and time, okay, it's a four thing. Okay, 3 dimensions of space, 1 dimension of time. Okay, 3 dimensions of space as we had, and 1 dimension of time. Okay. Now, in the black hole, the space becomes time. Time becomes space. In general, as I explained, the dimensions of space and time are nothing more than dimensions. These are just dimensions. It's just the tug of war which are defining, which are making space and time, special. Okay. Otherwise, they are just random set of dimensions. These four things. Okay. So inside a black hole, they just switch their roles, and what was your space becomes time, and what was your time becomes space. So
How does it look like?
how does it feel like?
Yeah.
Okay, it feels just like a normal universe. It's just that your time becomes space and your space becomes times. Maybe some people say that past is recorded, and if the past is recorded in time, okay, if the past is recorded in time, then maybe you can see your past, because time is, if time records, if the dimension of time records the memories. Some people say that that time doesn't record, the universe doesn't care for the stories of the past or the stories. Yeah, that's the idea of presentism. I especially myself especially believe in presentism. But okay, if the time records the past, then then when the time becomes space, switch it roles to space, then you may look like, okay, if time becomes space, imagine like time right here in front of you. When I was in college, I was right here. When I was in school, I was like, back to it, like in dimension, okay, in space, okay?
Timeline.
Timeline basically. So when I was in college, I was right here. I'm right here. When I was school, I'm right here. When I was old, right here. When I'm going to my kid, I'm gonna. It's right here. So you literally direct things in time, just like you see in space. For example, where is your mic? Here's your mic. Where's my mic? Here's my mic. That's what we do in space. So you be like, if time records the past or time, yeah. So it be like here is my past, here is my future, and here is my present. Will be entirely like that. So if time records it, but I especially believe that time doesn't record. Okay, that is the idea of presentism I believe in. So if it, yeah, so in a black hole, it just appears. It's also called a pseudo universe. Pseudo universe, because even if space time coordinates get switched, it just feels like a normal universe itself. But here comes the interesting part. The singularity sucks.
Yeah.
It breaks time. And once it's like, imagine this is the edge of this paper. Okay, after this, the paper does not no longer exist.
Hmm.
Okay, but
Hmm.
this is a point in space.
Hmm.
Similarly, the time is also a space, right? Imagine this is a time. Okay, now imagine this. Yeah, imagine a time. Okay, now what happens is that time itself breaks inside the singularity. The time does not exist in the singularity. It's like it's a singularity in time. It's not a singularity in space. Okay, singularity in space.
Not getting you. Not getting you.
Okay, fine. Singularity is basically a boundary after which time doesn't exist. Time doesn't exist. For example, after this boundary, space doesn't exist. This is space.
Hmm.
Paper, this is two-dimensional space. Okay, so after this boundary, space doesn't exist. But similarly, the singularity of a black hole is a singularity in time. It's a point after which time doesn't exist.
But what does it feel like when time doesn't exist?
Everything, for example, this pen has its meaning defined by the existence of space time, because every atom in it has some quantum frequencies attached to it. Okay, it has time as a measure. Okay, it has a time of a measure of its very existence. And where there is no space time, there is no matter energy. There's no matter at all, right? There's no matter at all where there is space time. I mean, where there is no space time. I mean, so after singularity, if there is no space time, sorry, there is no time. You just forget about space time. Space time returns to the hyperspace. That's how. S- Again, singularity is the break in time. Okay, it.
I just want to know how
yeah.
it looks like, how it feels like. Like if you were to look at it,
Hmm.
what would it look like?
Can you look in time?
I don't know.
You can't look in time.
I don't know.
You can't look in time.
I
Can you look
mean,
at it?
when you say look in time, what do you mean?
For example, let's say after this podcast, let's say you're going to have yeah, there are two chances. Either you want to have dinner at your home or you will go outside. There are two
Yeah.
chances. But you can't say you can't see that what you are choosing, right? You can't see. You don't know. It's it's choice of
looking
later.
in time.
Looking in time,
Hmm.
right? What you're doing, looking in time. You can't look in time like on a television. Like I'm going to do this. I'm going to do that. It's a message from the future. No, it doesn't work like that, right? So it's a break in time, basically. The singularity, it's a singularity in time. It's the point where time, after which time doesn't exist. And what makes, and the tug of war of speed of causality doesn't exist there, because
So what exists?
just hyperspace. Singularity is the gateway to hyperspace. Imagine that way. Just
That you told me
hyperspace.
about the cubes coming. I mean, the floors coming in and becoming a part of each other.
That was just to explain how bizarre the hyperspace is, the
Uh-huh.
extra dimensions. And that was just the 4 dimensions, bro. Hyperspace scales from 0 to infinite dimensions. Infinite dimensions. So hyperspace is all about.
But even on Earth, I can't look into space. I can make up my mind and feel like, okay, fine, I want to stay back home. I want to eat my dinner. Or I want to go out and I can eat my
But
dinner. But I can't look into it, right? But I can look into my past because those things happen and I can go back and, okay, fine, this is where I had my lunch today.
Yeah.
That time I woke up. This is how I traveled. I can imagine it in my past. I can see it here and I can visualize it, right?
Yeah.
I can't look into the future, but
Yeah.
it will happen and then I can look back into it. So when you say singularity, what I mean to understand is if I'm there as a subject or if anyone is looking at it, like the point of views of that person, क्या दिखेगा?
Just imagine right now, okay, like that we reach the singularity right now. What
Okay.
happens?
Huh.
We return to the hyperspace. Nothing exists. Nothing exists. I mean, it feels like if you, I mean, nothing exists. It's like maybe a blackout or maybe a whiteout. We don't know how hyperspace looks like, how it's been outside the universe. We know nothing about it. Either it's full of energy, either it's full white, or either it's full black. We don't know about it. Okay. So the topic of what happens at the singularity, how it feels like, is the topic like what happened before the Big Bang. Because the Big Bang, if you talk about Big Bang, is also singularity, right? Big Bang is the before Big Bang was the non-existence of the universe, right? Before the Big Bang.
Non-existence of the universe.
Universe didn't exist before the Big Bang. Fine. Universe began at the Big Bang. Before Big Bang, there's no universe.
But how did it begin?
Okay, fine. We just talked about it. It began after the tug of war. Okay, let me complete. Okay, so singularity of a Big Bang is same as singularity of a black hole. They both show that hyperspace case where there's no space time, and where there is no space time, there's no universe. And how does it feel like? It just feels like hyperspace. How does hyperspace feel like? Once we, I mean, this is the I just said hyperspace feels like omnipresence. Everything is present right here. It's a mind blending, something our mind can't think of. It's a 4-dimensional thing.
I can't imagine it.
It's a
now.
high-dimensional
I really
thing.
can't.
It needs practice. It needs practice. It needs
Studies, focus,
Explain-
like
Exactly.
theory,
it
not
needs
therapy theory.
theory. Exactly. You need to strain your mind a bit for it, because right now I think is it something we are hearing for the first time?
I am.
So that's why the first time I read this, I was like, what the hell is going on? It is like that. It is, you're playing with reality. You're not playing with a paper. I can do anything with this paper. I can, I just can, like I can do this, I can do that. I can just make a rocket out of it. I can do just anything out of it. Okay, of this paper. Imagine same thing doing with universe, not just this paper, but something which is 4-dimensional, and try to imagine it. This is how complex it is.
That's what hyperspace is.
Hyperspace is 0 to higher dimension. Yeah. Basically.
Anything and everything exists at the same time. Nothing exists.
You can say that. That's one of the conclusions. Not one of the conclusions, but one of the things one realizes in hyperrelativity, that even if the universe exists, it's like not existing. Something that exists but not existing. You get a lot of meaning out of it. It's very
I mean, it is like
detailed
Shiva. It
explain.
is like Shunya bhi mein, sab kuch mein. It's like, infinity. It comes back to its
the hyperspace perspective.
Yeah.
It is a hyperspace perspective. Like something that exists but still not exists. It's there, but it's still not there. I mean, it's like that. Look, we feel time, okay? Like our time is going on. We are heading towards the future. But how does it look from the hyperspace? The universe just looks like it just looks like a peanut. Okay? It just looks like a peanut. Future is there, past is there, everything is there, everything is omnipresent. Everything is omnipresent in the hyperspace perspective, because everything is just omnipresent right there, right? So you get a lot of conclusions out of it. It's very detailed explained in my book, Hyperrelativity. It's all about hyperrelativity, universe, and relativity. Amazing thing. Amazing book it is.
Why do we exist? How do we exist? Why do we get old?
You asking about the purpose where we are existing
No,
here
I
for?
mean just from the universe's point of view.
I mean, of course, we have that theory. I mean, of course, we know, like, as the earth created, Big Bang happened. Then after that, the first element we got the hydrogen. Okay. The hydrogen gas clouds came together, formed stars, then we have solar systems. Then we have planets like Earth, especially our Earth. Then we got like various impacts with the earth. We got the moon, we got the water. Okay. Then we got the DNA, then we got the first cell, then we got for unicellular to multicellular to us. That's how. That's the animal picture. But if you talk about the next level observer effect, the universe has been created under the cause of us. And in next level observer effect, it's a hyperspace perspective.
So you're talking about God particle.
God particle is basically, we're talking about Higgs boson, right? So in hyperspace perspective, you can present create the past? Can it?
Yeah.
How can? Let's say a child gives birth.
Because right now what is present will be the past.
Of course, but what I mean is, can past create the present? I'm sorry. Of course, it can create, right? But
How?
that's what we call. Let me just a second, okay? So when you talk about, so when the present, for example, humans came after 13.8 billion years. Earth was created after 13.8 billion years. Okay, so can I say that the universe was created by humans?
No.
Because we can't create the past, right? Past is already created.
Yeah.
We can't. How can we create past from the present? I mean, so when present creates the past, there's when we use the term of created under the cause of. the past was created under the cause of the observers.
Fuck, man.
There's a Boltzmann brain argument talking about the
Present
same
creates the
thing.
past.
Because at a hyperspace perspective, what does dimension of time look like? It just looks like a line, just a single straight line. Why does this point on, if I draw like 3 points on it, one both of so one point on its one side, one end, and other its other, and the one point on its other end, and one in the middle. Okay, we have 3 points right here. All right. Why should, now just check it, citizen, why should this point be the creator of this, or this point be creator of this be of this be of this? It doesn't make sense. These are independent points. That's the hyperspace perspective. So present can be the creator of the past, and when that happens, you use the word the creation, the cause of. It's very detailed explained in my book, The Next Level Observer Effect. Yeah.
But I think you're right here. I mean, present does create the past.
For example, let's say there's an egg. Okay, in egg there is a cushion. There is a cushion for the chick inside it. Okay, so think of it like before the egg, before the life even arrives inside the egg, after like a long time, the first the egg starts to mature. Before that, there's cushion is there, so it's like the cushion is ready for the life that is going to form inside it. Similarly, the universe and everything is getting ready to support the existence of the observer, and a secret thing that is mentioned in my book. Plus, that should be a plus. That not should be like, I can't talk about that topic. It will take into spirituality. Okay, plus that secret.
Where does all this end? I mean, what is the ultimate conclusion or the meaning behind all this? Like, what is? Because all I can understand is that it's all mysterious. It's all
Meaning of
mystery.
humanity, you are saying.
Meaning of reality, rather.
The meaning of
Reality.
that's what the
we are
next
in
level
reality
observer
right
talk-
now, right? We are in reality.
That's what the
reality.
exactly. That's what the next level observer effect talks about. It connects the reality with the observers of this universe, and when it connects it, you get the purpose of the universe, why this universe exists, and what we here for.
Why?
That's the secret thing. I can't talk about it. Should I?
Go ahead.
To be honest,
Yeah.
oh my gosh, it will be a totally misunderstanding. To be honest.
Go ahead. I'm ready.
Okay, fine. Okay. It is the universe has been created under the cause of observers.
Which
Plus-
are observers are
Us.
only us. The other elements around us that are created by.
This everything in the universe, like matter, energy, and everything, what we count about. Everything has been created under the cause of us, plus us serving the God. Not God as a creator, but when you look at that level, you see God in everything. That is a hyperspace perspective. You see God in every single thing.
Yeah.
That's I mean, maybe for to tell, it'd be like, what is it saying? But you have to go step by step through my next level observer effect book. I have blended it like I have like
So you believe in God?
me.
Yeah.
Yes, I do. Not someone like God, whether God has created the universe. No, the God hasn't created the universe. The universe belongs to God.
Define God.
Everything and nothing, both.
That is Shiva.
Not Shiva.
Because that's how
It can be-
That's how Hindu scriptures define
Yeah.
Shiva.
Yeah,
Everything and nothing at the same time.
not just Shiva, but like, yeah, I mean, they are the same thing at the end of the day.
Okay, define God from astrophysics point of view.
Astrophysics doesn't talk about God,
Then why are you talking about God?
because it is not just about God. I'm also like expert in spirituality. So it's spirituality plus astrophysics.
But how can you be so sure about it that it is the reality? Because this might be just your own findings.
Yeah.
And who's there to verify it?
About what?
When you said plus.
Okay, so you want evidences, right?
Yeah.
So in my book, The Next Level Observer Effect, there's the science of evidence. When we ask for evidence, whether that is symmetry tending evidence, non-symmetry tending evidence, if God comes in front of you, the first thing you will be wanting God to do is perform magic, right? If someone says that he's a God, what do you say? Can you just leave this pen in front of me? Like, right? Maybe a magic. So it's not about just that. It's about the science of evidences we ask. Asking evidence is good, but understanding the science of evidence is crucial. So it also teaches
Okay,
the science
asking
of
evidence is good, but understanding the science of evidence is crucial.
It's crucial
Okay,
to
okay.
ask the right evidence. People ask wrong evidences. In this universe, if I let's say for example, you know, do something to the for example, if I change the value of speed of light, let's say if I change the value of epsilon naught, which is there in the electromagnetic field equation, that's one of the one of the fundamental constants of the universe. If I change the value of it, what is going to happen? It's going to alter the electromagnetic force. And if the electromagnetic field force becomes less powerful, what happens? If the mountains can fall, okay, because everything is if everything is, for example, this paper, it is like, it is stable because of the electromagnetic force between the atoms, right? If that loosens, if that
It will change its
structure,
internal
I mean,
dynamics.
yeah, it assembles into the particles, it just, atoms just get fragmented and all those stuffs.
So you said the observer effect plus our service to God. And when you say God, it doesn't mean like the one who created the universe or anything.
The universe belongs to God, as said.
God asset.
As
God,
I
I
said.
said. Okay.
Yeah, as I said, the universe belongs to God. It's not that God has created. Or so, Raj, this topic is just not about just hearing about it like for 5 minutes or 2 minutes or something and taking misconceptions out of it. It's not just about that. Look, there's a process. For example, if you want to create a good pizza, you just can't throw it into a rocket engine. Okay, it will be just ash. A pizza will form into it will be converted into ash, right? There's a process to make a pizza. Similarly, the statements I am making in this, like just what I said, there's a process to get at it, which the purpose which my book, The Next Level Observer Effect, is serving, basically. So you have to go through the process. Just don't hype up, just I said that, but you have to go through that process, read the Next Level Observer Effect book, and just see.
Okay, fine.
Yeah.
I saw this image where all this Bhumandal, hum kehte hain Hindi mein, right? We got it Bhumandal. A lot of you must have seen on Instagram reels. So there's a picture also of Vishnu, the creator, I mean the Palanhar, as we say, the one who takes care of, the protector.
Okay.
So according to Hindu mythology, there's Brahma who's the creator, there's Vishnu who's the protector, and there's Shiva who's the destroyer, right? So Vishnu is lying on Sheshnag.
Yeah.
Okay, that's where he rests. That's his bed, and around him are globes,
Yeah.
globe-like figures
Mm-hmm.
that are called as universes,
Yeah.
Bhumandals. So
Okay.
do you think that is also one?
You know what is that? Where is where is Vishnu, Lord Vishnu laying?
I don't know.
He's laying in hyperspace. What happens in hyperspace? If you check that image, like closely, then the Vishnu has like a lot of hands, like Vishnu avatar,
Yeah.
has a lot of hands. That is the omnipresence. Whatever operates in hyperspace, it's all about omnipresence. It's all about omnipresence. Okay, so that's what happens in hyperspace. And if you talk about the individual universe, Vishnu basically lies in the hyperspace in that image. And something, in India, it is the images from India, and it's really amazing, that people could think about not just about the parallel universe, but also there's multiple hands, which it's all about the omnipresence, right? It is all about the omnipresence. And thinking about omnipresence back then. Think about it, right?
So do you think Hindu mythology explains the concept of infinity, creation of universe to a very certain precise?
To be honest, right now I haven't explored much about Hindu.
Okay, you know about Shiva's Damru?
Yeah.
So when he plays it, it's like this. That's how it plays.
Yeah.
And it creates a sound.
Yeah.
Okay. But then the swing of it, the
Mhm.
rotation of it, the movement of it, it ends up creating the symbol of infinity. You see? This is infinity.
Okay, I'm picturing it.
Yeah.
Okay.
This is infinity. Like this.
Yeah, it is infinity. It is
That-
like infinity is
yeah,
like that. I mean,
it's an infinity sign, right?
yeah.
So what it basically says that I have no start, I have no end, I am and I am not. That's what it says.
So yeah, I mean, there are a lot of things, to be honest.
So that represents hyperspace where Vishnu is lying, and this represents infinity, the expansion and the concept of boundaries which exist and do not exist at the same time.
Yeah, I mean, yeah, exactly. So in hyperspace is endless. It's infinite dimensional. Infinite dimensional.
But aren't these just theories? Because nobody has seen it with naked eyes.
You know what is you're saying? You're doubting hyperspace.
I mean, I haven't seen it. Nobody has either.
You know what? Let me shock you, okay?
You have been shocking me since the last 90 minutes.
Gravity is fifth dimensional.
Where?
for example, I have this paper. Okay, this is two-dimensional. All right.
Mhm.
When I curve it, it gets height.
Yeah.
It becomes a three-dimensional structure.
Hmm.
Gravity is nothing but a space-time curvature. The same curvature which I got in this paper.
Yeah.
There are a lot of theories like Kaluza-Klein theory, which is about the theory of everything. Won't be discussing about it much in detail about it. It's very complex. Okay, and yeah, so it even the it becomes what you say easier for us to encompass things when it comes to extra dimensions. Okay,
So do you think a lot of dimensions haven't even been explored or discovered or understood yet?
it's just our fault that we can't imagine more than three. Dimensions range from 0 to
If
infinity.
we quote that again, it is just our fault that we cannot imagine more than 3.
Yeah.
Some of us
Dimensions
are
range from
stuck
0 to
still in
infinity.
2. Some of us are stuck still in 2.
No.
Yeah.
We can see, for example, this mic. It has some length, it has breadth, it has height. We know how it's 3D. We know it's 3D. And to be honest, I don't think we can. Yeah, of course. Yeah. We can imagine just from 1 to 3 dimensions. Like 0 dimensions, we know 1 dimensions, we know 2 dimensions, we know, and 3 dimensions, of course, we can imagine. The world.
So
is,
what other things
three
interest you now?
This spirituality, and not just spirituality. Now I have been looking this universe and spirituality as the same thing. I don't say reality and spirituality. I think the reality is just a small part of spirituality.
So when they say that, there will come a time when the size of the sun will increase,
Yeah.
it will go on, and then it will
It'll
kind
eat
of
the
like
earth.
gulp, it will eat the earth. Do you think that's a reality?
Of course.
But at a very longer
5
stretch.
billion years later.
Until then, probably would be somewhere else.
Yeah. Let's say 5 billion is a huge amount of time for us to.
Huge. It's super huge.
Of course, it's
Yeah.
astronomical. It's astronomical. Even 5. Yeah, it's astronomical. It's cosmological scale. Okay, the universe is just 14 billion years old.
So do you think
30.8.
we are just going to leave Earth one day and say goodbye?
I think it's enough time for us to build technology to just leave.
But what about other life planets? Do you believe in other planetary life?
Of course, I do believe in it. Yeah, I do believe in it. Microbial life. Yeah, of course.
What?
Microbial life
Microbial lives.
can be are possible. Yeah.
So do you
In
think there can be
Europa.
space wars or something?
Yeah.
Do you think there can be space wars?
Uh,
Like other kind, like some other space kind that is just coming and seeing us as a threat.
to be honest, personally, I don't think that. I don't believe
No, but
in
do
that.
you think that there exists life apart from our planet also?
Of course, I do.
Like there are humans, bodies like this or something else altogether?
Not like that. I think life in the form of microbes or life, like maybe a bit of complex life as well. A bit of.
But why can't they be more advanced than us? They can be, right?
Again, you have to read the next level observer effect. There is an argument for this. There is an especially huge argument for this. And to be honest, you think having life is so easy. Let me tell you, when you talk about the Earth, okay, tell me a planet. You go search for in the entire universe. Show me a planet that Earth-sized planet that has a moon as huge as Earth. Venus has no moon. Mercury doesn't have a moon.
Jupiter has insane amount of moons.
But it is not of size of Earth. I'm talking about planets that are near to the size of Earth. Near to the size of Earth. Jupiter is huge. It's many times
Insane.
larger than Earth.
Yeah.
Insanely larger than Earth. Okay.
Yeah.
So we talk about planets that are like comparable to the size of Earth.
Mars?
Yeah, of course. Mars just has two potato-shaped moons. Okay. So to have a planet Earth size and having a moon like that, and again followed by many activities, and like Earth, we got it so special. I mean, it's easy to create a microbial life, but not what to say. I mean, there are many arguments behind this. Something about rare Earth hypothesis, which says the chances are less, which I'm talking about right now, and also there are many arguments as well, which says that life is possible, but not maybe intelligent than humans. There are a lot of
But how can you say that? Don't you think that would be very ignorant to say or think, because we do not know the possibilities of the universe, because it is infinite. It is insanely huge, large, vast, already, and
exactly
every day expanding.
Exactly.
We don't know what's there at what corner of the world, and they are okay with the kind of habitat they have over there.
Yeah. Fine. I'm not against the aliens. I'm just against the aliens comparable to the intelligence of humans. I'm just for the, I'm just telling that I'm not against aliens. I'm just against the aliens that are comparable or higher than the intelligence of the humans. Because in my book, The Next Level
But
Observer
why?
Effect.
If we can exist, why can't
Because
they?
because let me tell you, okay, the to create a life, what do you need? What do you just why just can't you create a chicken baby just like out of thin air? Like that's what we call non-symmetric tending.
Because it has to go through the stages of
Process.
evolution.
That's what
There's so many things involved
That's what
behind it.
Boltzmann
Millions of
comes
years.
behind.
Yeah.
that's
I
what-
mean, humans came on the face of the earth after a million years of evolution, right?
yeah. So why does to create something we need the process? For example, why do we need the process? That's the symmetry tending universe. Our universe creates everything with highest symmetry. Okay. So for example, let's say if you have to create an apple pie, okay, which is a dish, okay. To create an apple pie from hyperspace, what will you do? You create a big bang, then you create stars, then we create solar system, then we create the earth, then we create apple tree, then
Yeah.
apple. Why is there a process? Why just don't create an apple from the hyperspace just like we create the universe? Because
Let's
things
do past.
in hyperspace you just can't, you can create it non-symmetric. You just create it like with a snap out there in hyperspace. But in this universe everything has to be done with a process. And you know, this universe goes with the highest symmetry tending process. Every process is created with highest symmetry, and it is that to create human like life, okay, it takes very high, I mean it takes very high non-symmetry. I think the creation of the humans is the highest non-symmetry tending creation of this universe itself. And if the universe is created under the cause of the observers, its target will be, let's say, create the habitat of the observer enough safe and enough that they don't get affected. I mean, to protect observers, create it enough safe that don't you don't need to create the other habitat of the observer. And so it's about the universe has been creating every single thing with the highest symmetry. Okay, so the creation of the observers, or what we are the observers, is very high non-symmetry tending creation. So it's explained very in detail, in my book. So in short, I will say that the universe doesn't want more high non-symmetry. It's all fit with it. It's just its goal is to create every single thing with highest symmetry. And having more observers in this universe, more alien observers in this universe, is like a high non-symmetry tending burden of this universe, which it doesn't care for, or which doesn't prefer to go for. It's really complex. Was it like very overwhelming? Was it? It's
I think I could.
There's a process. I
Yeah.
told you.
Yeah.
You just can't cook pizza on the rocket engine. There's a process for it. I can explain you every single thing within 10 minutes. But you will just lose the process. And process is also important to understand something, right? If you just explain every single thing like in a paper, and there's no process for it, you can gonna take a totally different meaning out of it. I know that there are trillions of stars in this universe, trillions of billions of galaxies itself, which have quadrillions of stars in it, and existence of human observers, it seems quite possible.
It
Okay.
seems quite possible because there are so many
It
possibilities.
is obvious. It is
Yeah.
obvious. But still, no. Let me tell you. If there are so many galaxies, no, so many universes, why aren't the intelligent aliens so common? Why aren't they common? Them If there are so many galaxies, quadrillions of galaxies, around the universe, those quadrillions of galaxies have like lot of stars in it, like a lot of planets in it, habitable planets. Look what Carl Sagan said. Let me tell you a quote. I really like this quote.
Yeah.
Either the aliens must be very common in this universe, very, very common in this universe, or there must be no aliens. No, nothing in middle, nothing. Yeah. Only
Just
two
us.
options.
Just us.
No, what I said, there are only two options. Either the aliens must be very common, or just us. Yes, we are alone in this universe. Only two options. What we are looking for, what people are looking for, is that are aliens common? Are we looking at them like that usually? Look, the universe is 4 billion years old. Okay.
Hmm.
To build a technology, maybe like to go from type 0 to type 4 civilization, I think billions of years is a huge, I mean, it's a like, you can do that within billion years. I think it's sufficient, okay, for them to do that. I think aliens must be very common, bro.
Common as in like they are among us, you mean to say?
To be honest, yeah. Look, there are quadrillions of galaxies. The aliens intelligent than us, like far more. Like aliens created just just 5 billion years after the Big Bang until now, like after 8.5 billion years, would have built so much of the technology if they're intelligent than us. So much of technology.
Yeah, because
And
even
there
one
must be so
proportion
many
of
of
it,
them.
yeah, it would grow exponentially.
Exactly. And there must be so many of them because they're near literally there's so many galaxies out there. If you check the globular clusters, there are so many stars out there, okay? So there's so many habitats. Why aren't they so common? And as Carl Sagan put it, either there must be a lot of aliens, either the aliens must be very common, super common, or there must be no aliens at all.
Or is it like just the way we haven't been able to discover out of a certain area that represents
Why
the solar
didn't they?
system?
Why didn't they went for us?
No, I mean to say, like, we have only been able to discover a certain
Yeah,
space area.
of course. Yeah. There's a
No,
limit
we
to
haven't
it.
been able to explore
Much
beyond
than
a
that.
certain point.
But-
So, what about they are also chilling in their own spot?
But still, the aliens having aliens who are interested in finding us, you know, still
I mean,
increases.
we are aliens for
Consider-
them and we are interested in finding them. We haven't been able to.
Yeah, of course. But we are searching for the aliens, right? We are
But
searching for the
there
aliens.
have been so many evidences in countries like South Africa and countries like,
To
America,
be
where
honest, there's no approved aliens at all, I think.
but so many UFO sightings have been there.
Yeah, it has been there, but nothing of them is at a scale approved that, okay, there are aliens. Or there must be something which is like, it is not approved. They are not approved at all. It can be anything. It can
But
be anything.
don't you think the state governments or the government bodies might be hiding it from us so that we don't get into panic?
Uh, I think I personally do believe that, in that we are the only intelligent observers in this universe. Aliens might
I think it would be a very ignorant statement.
Because-
Hiten, honestly.
because you haven't gone through the process which I'm saying. You go to the next level observer book and you get it. There is a process to accept this fact. If I just explained you about symmetry, not in
You're just killing all the possibilities when you have quadrillions in front of you.
Now let me ask you, why there are not billions of aliens searching for you? There must be like lot of aliens. We must have met, like for example, some alien came to
I mean, we are 6 billion people on a very small ass planet. So obviously there would be billions of other people out there.
billions. I will say quadrillions. A lot of aliens. Either alien must be very common, or either there must be no alien. Aliens, I think it can be in microbes. Okay, they can't explore and they can't. I mean,
They don't have a
much
structure like
intelligence.
us, you mean to say.
Not just a structure. I mean, there's a lot of things. It's just about what we even define as a technology and all. There's a process, Raj. There's a process.
Yeah,
For it.
I hear it.
You can't cook pizza on a rocket engine at all. Pizza has some process. You need a right amount of temperature. You need a right amount of time you put your pizza into the oven. So it is a process for it.
So do you think the observer effect for them is happening now, or maybe it will take some time?
We are the observers of this universe, Raj. And what I'm saying is you go through that process, and that process is what will enlighten you to what is there in the book.
Okay,
The
then
next level observer
tell me.
effect.
Okay, Elon wants to go on Mars
Yeah.
before he passes off and moves on to the next chapter of his life, because
Yeah.
I personally think that man is like superhuman.
Yeah,
He's
yeah,
an
yeah.
alien,
I'm
right?
interested in Mars. Yes.
Yeah, so I mean, why Mars for him? Why does he want to, capitalize Mars and build colonies, human colonies rather?
Firstly, Venus, it has a very dense atmosphere,
Yeah.
something which has a crushing pressure. Mars is not crushing us. But since I like the fact that Elon Musk, is, pushing our boundaries. But to be honest, it's I mean, I don't think, because the air of the at Mars, isn't breathable. You can't breathe it, right? It's just CO2, right? You just can't breathe it. And water, we are not sure whether there is water. Scientists say that
There were traces of water bodies there.
exactly. Of
Yeah.
course, there was water on Mars
Yeah.
billions of years ago. Some people say now, many scientists say that it's beneath the crust of the Mars.
Uh-huh.
Let's find it, but it's a difficult mission, to be honest. Difficult because firstly, you go to the Mars, then you wait for the transfer window. There's a time to go to the Mars when it's nearest to the Earth. If you just miss it, you're gonna lose a lot of fuel. lot of fuel.
Yeah, so he's basically aiming it with a trajectory like when it comes to nearest to the Earth. And that's when it's going to
That's
go there.
so yeah, Raj. So it takes right time and right transfer window to you for it. It takes right time for you to go from Earth to Mars. Basically, when the Mars is right, near, very near the nearest point of Earth and Mars. That's where it's best to travel out. It's gonna take a lot of fuel, bro. It's gonna take a lot of fuel. So and just building the colony on the a colony on the Mars. It's time consuming. Also about air there, water, lot of stuff. So I support Elon, and yeah, let's have it. Going to Mars. It's difficult, of course. It's complicated. It's time consuming, but possible.
Have you heard of those transport services that he will soon launch? I mean, that's in his agenda, obviously. So I'm pretty sure that he will do it. Like he wants to make transfer so easy that from Tokyo to New York it will take you like 20 minutes.
Oh wow!
So it's basically like those launch vehicles. You will sit inside them. They'll launch from the launch pad, and then they will travel.
Yeah.
And they'll be landing at the SpaceX base in that country.
So I once launched the Starships launch within 45 minutes. It was launched from Texas, I think.
Oh, you were there?
I was not in Texas that time. I was watching it from Mumbai. Okay, so I was live. Okay, on the it was online. I mean, it was live on the YouTube. Okay,
Mm.
so just went from Texas to Indian Ocean within 45 minutes. So we need to talk about ballistic missiles or whatever we have in countries. They can deliver anything, a bomb or anything within 30 minutes. Like if you're just talking about from, let's say, from Mumbai to New York, you're going. I think you can literally deliver it at within 30 minutes.
But
Well-
how will it feel like, huh? Once we are there, I mean, we're literally flirting with the concept of time because we have never been able to achieve that sort of a speed before.
We have the Voyager 1, we have Voyager 2. I think the Parker Solar Probe is traveling at whooping it's traveling at the fastest speed. Yeah, of course, I'm sure about it. The Parker Solar Probe, which went into the sun, is traveling as the fastest. It's the fastest
What?
human
It went
probe.
into the sun.
It went into the sun. Yeah, it went into the sun. The
What-
Parker Solar Probe.
What is that?
A Parker Solar Probe is basically, it's NASA designed thing to explore the sun, basically, and it will just go inside the sun. It wants to study the corona, the corona of the sun. Yeah, sorry, the corona of the sun, which is the sun's photosphere, basically. Okay, it wants to study it. All right, so it
6,92,000 kilometers per hour.
yeah, that's the fastest human made thing we have, and that's an immense speed, right? Think of going from to Mumbai to London at this speed. How much time it will take? It will take it will take seconds, of course. I mean, yeah, literally it will be like this. I mean, so that's not the fastest thing. In space, we can go at any speed. Any
And
speed.
now
we can
just
go.
compare it. Since now we can imagine this. Now compare the speed of light. Damn, it's
Damn, time doesn't exist for you if you travel at the speed of light.
you're just everywhere and anywhere, and yet nowhere.
Omnipresence. You're just
Back to it.
omnipresence.
Back to it. Back to it.
Yeah.
What do you think about Area 51?
Area 51. To be honest, many people have like a lot of theories for it. Aliens there, some US technology out there, which this is
Yeah,
not.
but it is restricted, still.
Yeah, because I think it is.
And one of the best watched and the most watched podcasts on Joe Rogan show is of an Area 51 episode,
Yeah, yeah.
where the scientist who used to work inside it was the chief guest. And he said that, I'm not sure whether he used to work in there or something, but he was related to it and he spoke about some ill shit. Something really
They must be
unimaginable.
like, I think 40 to 50 years ahead of technology. If it's a secret military base or something research, is going on there.
Yeah.
So it must be like a lot of it must be like decades ahead, like what technology we have today, a lot ahead, like what we have today. So yeah, I think it's just like some research facility which US wants to hide it from the world, as like what every defense research facility does all around the world. in every country. It's just US hiding it, I think. I don't know. Yeah, Area 51. It can be. I mean, it can be like they're hiding something. I think that technology is what they're hiding, anyways.
What's there for you next? Like, what's up and coming for you now? What are you working on now?
Right now, I'm also researching on some topic on gravity, and new book is working on books.
What's your source material?
Source material, like you know, like lot of books and lot of lectures and research papers and all those stuffs. Like,
You
yeah.
dig deep into it?
Of course, there's a time where I used to be like, there's was mathematics from, but as you go older, as you grow older, I just mathematics becomes easier. Like,
Dude, you're just 22. You're just 22.
yeah,
You're just at the tip of, the youth or the prime of your life, and to have this amount of knowledge and to have so much interest and read so much about it and grasp all that gyan and keep it into you and constantly evolving, I mean, it deserves a respect. It deserves a salute for sure. And it speaks about the passion, and it's pure passion.
yeah,
I think you should pursue your doctorate or something into this.
of course.
Yeah.
I think I have a knowledge of a doctor itself. Right now I'm 22, so I literally I have my degree in BSc, but I think I have knowledge of doctorate level of PhD level. Of course I do have. I'm pretty sure about that.
Because of the material that you've studied.
Yeah.
Do you ever question the material that you study?
A lot of questions.
No,
but
question, I mean, like, do you doubt it?
of course,
And then how do you come up with the conclusion then?
I doubted about the material. I went to the professors. I went to the people I know who are great in astrophysics. Like, yeah, sorted it out of there.
Okay, when you imagine space, what do you imagine? What does it look to you in your brain?
Space.
Yeah.
I just look space as a freedom of motion. You can walk there, walk here. I mean, hyperspace. When I think of space, the first thing that comes into my mind as the author of hyperrelativity is the hyperspace. Infinite dimensions, 0 to infinite dimensions.
If Albert Einstein was here with you or in front of you, what would you have had spoken with him or asked him about?
Asked him about, like, to be honest, I think I don't have like relativity, I understand it very well. I mean, of course Einstein is great. He's a great figure. He's a great man. But I will really, instead of asking him, I would really love to, just talk about relativity, just random talks with him. I just love to have random talk, I will just talk about relativity.
And what do you think he would respond or reply?
Yeah.
What do you think like his response would be?
He's Einstein. So, in universities, when he used to teach other subjects than relativity, special theory, general theory of relativity, it was his boring time. But when it comes to relativity, Einstein, it's history, basically, that Einstein always loved to talk about relativity. So, it will be an amazing interaction between us.
Do you think it all began with him? Because space studies are not that old. I guess just what, 50, 60 years of age?
Wo?
Or more than that?
Wo?
Space studies.
Space studies.
The studies of space.
Well, Einstein got his theory of relativity in 1916. So it's more than 100 years, right? Firstly, but we are talking about those, Vishnu and all those hyperspace.
Yeah, those go back like lakhs of years before.
Yeah. So technology comes in. Sometimes, like, Takshashila University burned into the fires.
Yeah, more than 1 lakh books.
Exactly. Technology comes, it goes. We don't know what technology we had.
We don't know what we lost.
Exactly.
Exactly. You're super right about the fact that, we did not know what technology we had. And maybe there was just a brink of time and then we lost it all and we probably built it all from scratch.
It would have took so much effort to build that technology and just fire and just, if technology has to go, it just can go within hours, like,
And then to start from scratch, that would have costed us more years.
Yeah. So theoretically speaking, by theory, we don't know whether it was the theory of relativity was just a thing about, because it's just thing about 100 years or before. Yeah. So I mean, we can't. But yeah, 100 years ago, Einstein had it, like 1916, more than 100 years.
What's your take on Mr. Hawking?
Yeah, he's an amazing guy. I like his black hole entropy formula. It describes it really well. And he's explaining brief history of time. We have like a lot of his books, And yeah, amazing guy. Also, Michio Kaku is also good. One of my mentors because like not he personally taught me, but I read his books, so I watched his videos. So that I mean, he's kind of my teacher, to be honest. Yeah, maybe I couldn't ask a doubt to him. He must be too busy, I think. I don't know about that, but I read his books a lot. I used to watch his videos. There is his book Hyperspace. Amazing. It's on Hyperspace.
What are some of the books that you would recommend for our audiences to begin with astrophysics along and apart from your books as well?
The books I will suggest to the audience will be like Black Holes and Time Wars by Kip Thorne, Hyperspace by Michio Kaku, and we have Parallel Worlds by Michio Kaku, and we have Cycles of Time by Roger Penrose. And it's an amazing book again. It's a cosmology book, and it's really amazing. And maybe you can have astrophysics for the people in a hurry. Some people found it like like, difficult a bit, but okay, you can have it. So yeah, this is the book recommendation I would give.
And movie recommendations.
Okay. Interstellar, must watch it. Watch it a lot of times. I've watched it 12 times almost. So Interstellar is something you must watch it. Must watch it. Gravity is also a good space science movie.
Gravity scared the shit out of me.
Oh,
Yeah.
amazing! You watched amazing, amazing. Yeah, Interstellar will do the same thing.
Yeah.
Yeah. So Interstellar is there, Gravity is there, Martian is there, Space Trek. I think it was 90s, right? I never watched Space Trek, to be honest, because it was not in our era. Our era is Interstellar, right? I'm born in 2003, so let's be after 2003. Interstellar is recent, 2014. Yeah, this year it was re-released basically. I was like, in 2014, I was a kid. I never knew about this movie. Okay, I was just 11 years old. I was like, I don't know about this movie. But this year, 2025, it was re-released. It was just amazing. The same year, my book on relativity came.
Fantastic, yeah.
Yeah, so it was just amazing experience, and I just love Interstellar movie. If you check the black hole of the Interstellar movie, it's created very so accurately by Professor Kip Thorne, and he's also Nobel Prize winner. And yeah, he's simulated black hole so damn well in
I mean,
that.
how it would look like.
What?
I mean, how it would look like.
Yeah, exactly. And we also got the pictures of the first black holes, and yeah, it's just an amazing thing. That image of the black hole, I'm something. I just got. Are you serious? This is the image of a black hole. This is a real image of a black hole. We just got through Event Horizon Telescope. We got the M7 black hole image for the first time. I think April 19, I think 2019. 19 April 2019. I got that image. I was like shocked. What the? Oh my gosh! We actually looking at the first image of a black hole. That's amazing. The image of a shadow of a black hole, basically.
And thank you so much for coming. Thank you so much for giving us your knowledge, your love, your passion, your curiosity, your imagination, which is beyond unimaginable.
Yeah.
And I truly had the utmost pleasure of hosting you, brother. And thank you for being so patient and so understanding with us. And your smiles, your sheer warmth and energy, I think it is going to travel faster than the speed of light.
Thank you very much.
And
Thank you very
guys,
much.
do not forget to please go buy this book from Amazon.
Yeah.
Right? The Next Level Observer Effect. Here's the cover of it. Here's the back cover of it with the amazing hairstyle, which were even more longer hair. What about your hair, by the way?
Yeah.
Why is it that scientists always have such, unique hairstyles?
Not just scientists, okay? Some people like in India, people said me, why do you grow your hair? I tell them,
Why?
ancient Indians used to have longer hair.
Yeah,
Why?
rishis.
Yeah, not just rishis. If you just see every man like used to have a lot of long hairs and
Why?
fashion India. I don't know about that, but it's not. It's just not about It's not just a Western thing. It's even common in India.
But doesn't it irritate you?
No, why does it?
You like it?
Of course, you take proper care. It's just
So there's no particular reason behind it.
no. There's no particular reason behind it.
All right, guys, go on Amazon, buy The Next Level Observer Effect, read it, leave your feedback in the comment section, connect with Hiten Shelar. He's one cool dude. He's one of the space kind, I would like to say. And this is just one of his books. There's so many. Astrophysics for non-mathematicians,
Yeah.
Astrophysics for everyone. And also,
Form of a story.
yeah, and also there's this cosmology for a newbie.
Exactly. And my new book, Hyper Relativity.
It's yet to release, or it released?
It's released. It's released. It's available on Amazon,
Yeah.
various marketplaces worldwide as well.
I mean, I had the pleasure of speaking to an astrophysicist, a scientific communicator, and a best-selling author. What more could I have asked? Beautiful evening, beautiful Saturday, 14 June 2025. Forever gonna remember this.
It's been a pleasure being here.
Absolutely.
Yeah.
And the beautiful thing is, like, we're doing it the day, we're remembering Sushant. He was deep into quantum physics. Oh, quantum mechanics. I mean, just imagine the chakras, present and the past.
Oh, yeah.
They're building it for the observers. Pleasure. How do you feel, brother?
Amazing. It's been a great pleasure for me being here and, expressing relativity, something which plays with reality, a tug of war,
Yeah.
as explained, amazing experience.
I hope I did not ask silly and stupid questions. I mean, I did ask, but
I can correct you, bro.
Clear.
I can correct you, bro. There's no worry about it, okay?
This is your podcast with Raj with Hiten Shelar. Thank you so much for watching. Like, share, and subscribe, and get in touch with him because he's one cool dude. Invite him because I'm pretty sure for every new podcast, he will have new stories. Thank you so much.
Yeah.